Hello again. Today we'll be looking at the deal or no deal game data from Kaggle. So I have looked at this in a longer video, but that was quite long. So if anyone is interested in the details, they can look at that. But here I'm just providing a summary of that. So the main points of that longer, more detailed video will just be summarized here. So Deal or No Deal is an American game show where a player is given a choice of 26 cases. Each case has a specific amount in it, amount of money, and they play against someone called the banker, and they try to make as much money as possible by the end of the game. So let's just have a look at a summary of what we found in the longer analysis. So the basic data, we had a data frame with 825 rows by 16 columns. We had 107 unique games or unique game IDs and no null values, so no blank cells. That was good. And then we had quite a lot of data cleaning to do. This 107 unique game IDs was reduced to 94 as a consequence of data issues, such as games with no round 1, inconsistent round numbers, so meaning that we had a game ID but it had round numbers such as round 1, round 2, and all of a sudden something like round 4 and 5 with no round 3. We had some with inconsistent remaining values per round, and games that did not terminate in a deal. So, for example, what I mean by inconsistent remaining values per round is that in the analysis we found that all round ones had remaining values 20, so all round ones had 20 remaining values, all round twos had 15, so that's consistent. But when we got to round 4, 5, 6, and 7, we had inconsistencies. For instance, with round 4, we found that some had 8 remaining values and others had 6. So looking further into it, for each of the rounds, we found that there was a clear outlier. For instance, with round 4, 98 of the games had 8 remaining values, and we had one with 6. So clearly the outlier there is the one with just 6 remaining values, and we removed that one and did the same for the other rounds. So formatting, the main formatting that was needed was formatting this remaining values column, which was a string, into the remaining values list column, which was a list of values. So by referencing the remaining values list, we can actually read the list and manipulate the data, as opposed to trying to read these numbers from a string type variable. Then another issue was round 1 and the missing round 0. So what I mean by the missing round 0 was that the games started off with round 1. So all games started off with round 1 and 20 remaining values. However, the actual game show starts off with 26 cases, and then you eliminate 6 cases to get 20, and then offers from the banker start. So the dataset initially did give almost a false impression that we started with 20 cases, and in previous iterations of this analysis I had made, for instance, the following mistake of thinking that we have maximum prizes, different maximum prizes for the games, such as 400,000, 500,000, 750,000, and so on. However, looking at the game in context and watching a few of the shows, I realized that this was actually the maximum that was left in round 1 after the initial elimination of 6 cases. So since here we see that there are values above 1 million that were left over, we did have games with higher maximum prizes or grand prizes, but it's not reflected by this. This is more what the highest number left after at round 1 after the initial elimination, and not the maximum for the whole game board. So it is a bit of a subtle difference if you do not have the context. And so, beginning with the analysis of the games, I had developed a game view, so to look at individual games via their game IDs, and I had landed on looking at a game by its rounds, so round 1 to round 10, through the offers shown by the gray line, and the blue dot being the deal. So sometimes this blue dot would be, say, at round 6, meaning that we had an offer given at round 6 and it was expected, and the rest of the rounds were post-game. As well as with the orange line, we're looking at the board average, and then the game average is just the average at the beginning. So in this case, since we start at round 1, this is the average at round 1, not the average of the initial game board before starting, or what I eventually termed up here as the missing round 0. And expectations, so what did I expect the other variables to be in relation to the offer? So primarily the variable of interest was more the offer, and when would you be offered more or less. And generally I did expect that the offer would be less than the board average. It wouldn't make sense for the banker to offer the player more than the average that's on the board, so majority of the time that is the case, and sometimes the player is lucky and gets a above average offer. Apologies, that was the wrong graph. This is the graph you saw, and this is the graph which is the correct graph and shows that the offer percentage of average seems to have a positive relationship with the probability of big value, which is defined as the probability of the player getting a value greater than 100,000. The graph is correct in the long version. Here we have an interesting offer where in the data you will find an offer that's greater than $1 million. So this is deal ID 67, and I had a look at it using the game view, and we see how the offers went with this gray line and how the average on the board increased there, as well as the average at the beginning or round 1, so the game average. So here, unfortunately, we see that the player took a deal at round 6, and then after that, things kept going up. So unfortunately, over here, the above $1 million offer was a post-game offer. It wasn't actually on the table. It was more of a hypothetical thing. And afterwards, also had a look at the winnings, so the deals that were made. So the average winnings were about $120,000. We're having a look at the distribution there. Also had a look at the winnings and participation by gender and race. There didn't seem to be any bias with these two variables. Distribution was okay. It didn't seem that any gender or any race was making particularly more money. And I also found that on average we would get a deal round about rounds 6, 7, and 8. So a lot of deals were being had there. So looking at, as mentioned before, the distribution of winnings by, for example, gender, fairly evenly spread here. And of course, most of the percentage of average is lower than 1, and participation seems fairly even, fairly reasonable between male and female, and of course non-binary is expected to be low as there's significantly less non-binary people in the population than there are male and female. And similarly with the races, given its American data, the distribution of the participation between races seems to reflect the American population. Okay. Another interesting thing was offers that were greater than the expected value. You'll find that these offers generally actually only happened during round 7, 8, and 9, so this was a late games thing. So that's as expected. You wouldn't expect this early in the game, as there's still a great chance of losing the large values and the player making less money. And so when offers were greater than average, one would expect that the player would more often take the deal, but we find that according to the data, when offers were greater than average, 14% of the time the player would take the deal, and in general, so not filtering for offers greater than average, they only took the deal 10.8% of the time. So difference depends how you feel about this difference. I don't really think it's that much, but yeah. And the question of how much of the game or the data is post-game, we found that it's pretty much a minority at 11.84%. So I took post-game to be essentially filler, because the deal had already been struck and no real money was at stake. It was simply hypothetical. So it's nice to see that a minority of the game, or at least the data, is filler. Also, another hypothesis, we hypothesized that as the game progresses, we'd have convergence between the offer and the board average, and yes, that is indeed the case. And here we have some notes, such as the fact that once you reach round 10, taking your case or swapping the case, that is recorded as a deal. by default in the data. So it's not a deal with the banker, but it's recorded as a deal, which is fair. And round one has no previous offers because you weren't given an offer previous to that. The first offer does come in round one. And also again the note that the data starts at round one, but the game actually sort of starts at a round zero. So as long as you're cognizant of that fact, that is fine, because the player only starts making real decisions after the initial 6 cases were removed, and you don't have a choice as to not remove the 6 cases because you don't have an offer before removing the 6 cases. So I think it is fine that the data was started at round one, but it is a bit confusing. It was a bit of an issue. And here I'm just looking at the initial board to see what a unchanged board would look like. So around a zero board, and we see that the average of the board is about $131,000, and so the board is heavily leaned to the lower side, even though the grand prize is $1 million. The average is even less than a quarter of that, so it definitely does make sense from a, I guess, gambling perspective that it would be leaned to the lower end. And yeah, that's that. And thank you for listening.